Welcome to this video on separable ODEs. We're just going to look at two examples and work through the solutions. These problems have no boundary conditions, but maybe we'll look at that in a future video. But let's get right into this. So, how do we know this is a separable ODE? Well, if we divide through by y squared on both sides, for y to the 5, to the 3, and let's neaten this up, but basically we can see that this is a function of x, function of y, separated. You know, in the actual form of a separate ODE, it should be dx by dy, or dy by dx, or whatever this differential is equal to one function of one of the variables multiplied by a function of the other variable. So a function of x multiplied by a function of y. But we could see that dividing through by 3x squared gives us that. We'd have 1 over 3x squared, function of x, multiplied by 4y cubed, function of y. So we're in a good position. What we're going to do is bring this dy up and then integrate both sides. So this leads to 3x squared integrated with respect to x, and that's equal to 4y cubed squared with respect to y. And this is the whole idea. This is why I didn't divide by 3x squared, because this is actually the form we want it in. And yeah, and the reason we call it separable is, you see, we've separated the x and y functions, and then we're integrating the function of x with respect to x and integrating the function of y with respect to y. Now this leads to x cubed is equal to y to the 4, and we have to add a constant of integration onto one of the sides, and I've chose this side. If we want to write that this is a function of x, we just take the cube root of y to the 4 plus c. That's it for this example. Move on to the second one. Right, so this time we're differentiating y with respect to t rather than differentiating x with respect to y. And to get this in the form of separable ODE, we're going to subtract 3ty from both sides. So now we've got a function minus 3t multiplied by y. So I'm going to divide by y and bring this dt up. So 1 over y dy equal to minus 3t dt, and then, you know, seeing as this doesn't really mean anything, we're going to just jump straight to the next step, which is where we integrate, and 1 over y integrates to ln y, or modulus of y, and this integrates to minus 3 over 2 t squared, and then we're going to plus a constant c. But then we're going to look to rearrange this, so y is equal to e to the minus 3 over 2 t squared plus c, and this means that y is equal to e to the minus 3 over 2 t squared multiplied by e to the c, by indice laws. And then what we're going to do is we're going to say e to the c, since this is just a constant, e is a constant raised to a constant c, we're just going to call that a, and then we've got y equal to a e to the minus 3 over 2 t squared. And that's our form. Now we've got y as a function of t, which is what we're looking for when we're solving a differential equation. You know, we want to find what we're differentiating as a function of what we're differentiating it with respect to. So y is a function of t, or before we had x as a function of y. That's it for this video. If it was helpful, then please like and subscribe. Anything else you want to see, then be sure to comment below. But for now, that's it, and I hope to see you in the next one.